Okay, people, I'm going to give you a very brief lesson on continuous variable valve duration, CVVD, brand new technology. Hyundai just made the first engine for it in their 2020 Hyundai Sonora 1.5 liter turbo beast of an engine. Anyway, so this is like basically what it looks like. So I got three different camshaft profiles shown here. Camshafts are basically they're like they're shafts. They're like these rods in the engine that I have shown here that like spin as the engine is cranking. Like obviously there's displacement. Like there's like, you know, the piston head moves up and down, and when the piston head moves up and down, it spins these camshafts above the engine. Hence overhead cams, which is like what every engine ever has now. So like that's the camshaft, these black shafts here, and then this like oval shaped thing is the cam lobe, which actually like spins with the camshaft. And that presses on top of like almost like buttons to open and close the intake and exhaust valves on the engine. So picture like there being one hole here. This would be the intake valve, and then there being another hole here. That would be the exhaust valve, and then down here would be the piston head. So like the intake, the air comes in, the combustion happens, the piston goes down and compresses, and then when the piston comes back up, the exhaust valve opens and goes out. So this is what just a normal camshaft looks like without variable valve timing, anything like that, just normal rotational motion. So the camshaft is spinning, the lobe is perfectly balanced, the intake and exhaust valves, I have them labeled. I mean, it really doesn't matter what color they are, but just know that one valve is intake, one valve is exhaust. Now, they're not right on top of each other in the engine. This is just a demonstration. Obviously, like I said, they're side by side, and it's just the cam profile depending on how much displacement there is on the shaft to make the shape of the cam lobe be oblong and its rotational motion. So instead of the cam being dead in the center, it might be like down here because there's a hole cut through this whole thing. So maybe the cam's down here. So this side is going to spin faster than this side is. So that's what this whole thing is. So this is when it's perfectly balanced, and intake and exhaust happen within the exact same like specification of time. So say it's 0.5 seconds for each. It's probably even smaller than that, but say it's 0.5 seconds for each. Intake, I said it's blue. So intake opens for 0.5 seconds. After the whole compression happens inside the piston head, the exhaust is going to be 0.5 seconds. That's what this is. These rotational motions are exactly the same. They're going to happen at the exact same time. That's all it is. This is a different scenario. This is a scenario where the cam lobe is shifted so that this cam, like the top of the cam lobe here, is actually farther from the camshaft where it mounts inside. So say the camshaft mounts here instead of in the dead center like it did on that one. Now it's going to mount down here, which means that this is going to spin. It's going to stick out more, which means that this rod is going to spin farther out than this rod is, because this rod's in shorter. And if you know anything about gears and gear ratios, this on the outside is going to spin faster than this on the inside. Because this is a shorter distance, this cannot cover as much distance in the same amount of time. Think about it. If you're having, say the camshaft is spinning at, I don't know, just say 30 meters per second. Now, that's not technically correct because rotational motion is a little bit different in specifications of velocity, but say it's moving at 30 meters per second. Well, this is covering more distance. Say this sticks out 0.5 meters. 30 meters per second times 0.5 meters. Well, this is going to cover 15 meters of distance when it spins around. But say this is only half that distance. Say this is 7.5 meters sticking out. Well, now, sorry, say this is going to be 15 meters instead of... No. Okay, I said 0.5 meters. Sorry. So say this is like 0.25 meters. So now you're going to do 30 times 0.25. And you're going to get yourself 7.5. So this is only going to cover 7.5 meters in its rotational motion. So this is covering more distance. This duration can cover more openings than this one can in the same amount of time. So the duration of this valve being open is longer than the duration. No, sorry. The duration of this valve being open is longer than the duration of this valve being open. Because think about it. If this side is spinning faster than this side is going to essentially be opening and closing the valve for intake faster than the exhaust is going to be opening and closing. So while this one might open it, because I said a 2-to-1 ratio, right? I said this was 0.5 meters and this was 0.25. this one would be spinning at this one would approximately be opening and closing its intake 2 times, while this one would only be opening and closing its exhaust 1 time within the same time period. And then this one's just the exact same thing, but it's just flipped. Now this time the intake is a longer duration than the exhaust is. So now the exhaust, like I said, that whole thing, camshaft spinning at 30 meters per second. This one is going to cover a distance of 15 meters. This one's going to cover a distance of 7.5 meters. So basically, this one's going to be spinning slower. The exhaust is only going to open and close once in that duration, but this exhaust is going to open and close 2 times during that duration. So basically all this is based on your engine load. These camshafts, where they mount inside of the cam lobe, which like I said is like a little ear thing that like spins, this will move up and down using electronics inside of its mount, so that one side of this will be oblong and one side will spin faster than the other side. And that's how you achieve continuous variable valve duration. And that is how Hyundai is innovating in their 1.5 liter turbo engine for the Hyundai Sonora in 2020.